Let's do a quick review of the history of the atom. And then we'll get into the final part that you can fill in your atomic history. So we started with Democritus. Democritus had the first idea of the atom. He simply had the question, are you able to cut something in half again and again and eventually run into something that you cannot cut in half any longer? He knew it was small. He didn't know what it was, but he thought there was a basic building block of matter, and that was the first idea of the atom. We moved about 2,000 years into the future, and a guy named John Dalton came along. John Dalton basically took a ton of different ideas, took a lot of misconceptions and issues that a lot of people were having, and organized them in a thing called the atomic theory. So you're responsible to know that John Dalton came up with the atomic theory. You do need to know those 5 items, which are in your notes. And if you were ever to draw his atom, you draw simply something that would look like a steel ball. He did not believe anything was inside of it. It was something very small and very solid. Along then came J.J. Thompson. J.J. Thompson had one of the 2 experiments that you need to understand. He had the cathode ray tube experiment. He put energy into a cathode ray tube and caused a beam of particles to travel across it. And when he put a magnet onto it, he caused the beam to bend. This beam bending proved that there were particles inside of an atom that had a charge. And he called those the electrons. So his model, which you can see right here, is called the Plum pudding model. And Plum pudding basically is saying that there are electrons inside of a cloud of positive charge. Those aren't particles. It's kind of like the pudding. It's just positive. His student came along then. His name was Ernest Rutherford, and he did the gold foil experiment. In the gold foil experiment we just did in class yesterday, he bombarded and shot alpha particles at a thin gold foil and was surprised that the particles were not simply bouncing off, or the pattern was not consistent with his expectations. And he realized that first, the atom was made up of mostly empty space, and the deflections that were occurring were consistently in the exact same spot in the atom, and that was in the middle. And he concluded and named it the nucleus, and that's where all the positive area is. And then he knew the electrons are on the outside. He did not know where, but he said that the electrons were in this empty space. The last name that we had discussed was a guy named Niels Bohr. And Niels Bohr did a lot of work on the physics end of this, but concluded that there had to be more structure to the atom. The electrons are not simply randomly outside of the nucleus. If they were, at some point, either they would lose energy and or just simply run into the nucleus, and the electrons would cause the atom to potentially blow up or destroy itself, and that wasn't happening. So he came up with energy levels, and that was his picture that you see in more of a 3D fashion, and that was Niels Bohr's contribution. That brings us to the present. And it's called quantum theory. So please put that as your last item in your notes. So this is I think one of the cooler pictures that can be taken. Obviously, I hope it is the United States. It is not AT&T's wireless coverage or anything like that, although it probably looks the same. What are you looking at? You are looking at basically a density plot of people in the United States in the evening. Right, here's Milwaukee, Chicago. Here is the Twin Cities, right? And so on and so forth. You can go into the Dallas and the San Antonio area, and San Francisco and Los Angeles, New York, Philadelphia, all that. This isn't the only place where people live, but these are the areas where there is a greater density of people. As you go out, you can see smaller lights in different areas that have a bit of light showing, but the majority of people live in extremely high density areas. We're going to call those a density plot or density cloud. So I hope this visual is going to kind of help us with what we're talking about, because what we need to do is take Bohr's model and take it one step further. Bohr said that the atom was literally, had energy levels where the electrons were literally on one rung or the other, and only there, exactly in one rung. So I took a picture of the school, and I'm going to make this up. Let's say our class has an experiment, and maybe it was to track, well, we could track, let's just track me for a second. Where would I be every 10 minutes of the day? So you have a clipboard and you have this map, and every 10 minutes your alarm goes off and you are required to put a dot onto the map of where I am. So where would that be? Well, this is where my room is. So in the beginning of the day, maybe you caught me, actually that is my car right there. So maybe there I am. Boom, there I am. And let's just say for some reason it did take 10 minutes for me to walk in. I'm a fast walker, but all right, boom. Oops, there I am. Well, then I'm going to start being in my own room for a while. So here's my room right about here. So maybe I'm there and I start hitting dots. Okay, maybe I'm walking around the room and you start to notice it's kind of a density plot there. Okay, oh, I got to go make a copy. Maybe I'm over here. Maybe I'm in the SRC. And as I do this, oh, I'm into the Commons. Okay, and I keep going. Oh, I'm in the staff teaching lounge. I'm eating lunch. I'm eating lunch. Come on. I'm eating lunch. Then I come back to my room. And you start noticing there's a plot. Okay, that's during the day. Right? Maybe I go to McDonald's. Boom. Over there. But then later in the evening, after school is done, well, now where are you going to find me? I'm going to be on the tennis courts. So maybe, oh, they look like tennis balls. Maybe I'm on the tennis courts. So now a new density plot's kind of happening. But basically, what am I saying is that there are only going to be certain areas where I am. But is it an exact spot? No. It's based off of probability. It's based off of probability. So what we are going to be doing is we're going to be talking about electron clouds. That's what this is. It's based off of electron clouds. So quantum theory is based on probability. Where the electrons are, it's all based on probability. So we are going to make some electron clouds. So one of them literally will be a circle, just with all sorts of dots. So all we can do is just put some dots. But as you gain energy, just like in my picture above, you notice like now I'm out here. I probably have more energy on the tennis court than maybe in the classroom. So I would have to maybe have a different kind of a pattern. So there's actually this other one, we'll talk more about this later, but kind of make a figure 8 or a dumbbell. It's just a different pattern. That's all I'm trying to get to you. So what that is at any time, that is 90% of where my electrons are, okay? 90%. So this is an electron cloud. And that's what we're kind of bringing to the table now. Either one of these, both are electron clouds. So is this right here. Oops. And actually, this is what one looks like right here. It's better than my drawing. So there I am. That's an electron cloud. So it is based off of probability. Well, how did we get to all that? There's a couple things that I have a video on next that I want you to watch. A guy named Heisenberg, he talked about the ability of trying to figure out where these are. Well, if I find out where they are, I have to slow them down. If I find out how fast they are, I never know where they are. So it's called the uncertainty principle. And then there was this other funny thing that kind of comes up from a guy named Schrodinger, who did some math that only maybe 5 people in the entire world probably can do. He talked about this thing called Schrodinger's cat, and I'm going to have Sheldon Cooper help us with that from the Big Bang Theory as well. So if I add to my final part of my review, go from Democritus, John Dalton, J.J. Thompson, Ernest Rutherford, Niels Bohr. Last one is we have quantum theory. And the picture is literally going to be a bunch of dots. So you notice this one, it kind of looks like an energy level. right? And where are most of my electrons? In this ring, like an energy level. But you notice that there are dots outside. There are electrons outside of it. So it's kind of wherever it will be. Uh, please do not get confused thinking that those are all the electrons in an atom. Just like my picture on the school, there's only one of me, but I put many dots because it's the possibility of all the locations that I could be at. So maybe this is only 1 or 2 electrons, but these are all the possibilities that they found that electron at in a certain time period. So a lot of times it was here. Maybe got a little more energy and it jumped out further. Maybe had a little less energy. Now it's in a little bit. So this is probability. So electron position based on probability is our final item for our atomic history. So let's watch a couple quick videos. These are really well done. You are not responsible for the names, but I want you to just understand kind of how they came up with electron clouds and everything else. It's based, again, the issues of how did they find the positions and the movement of all the electrons.